Hey everybody, hope you're all doing well. Tonight we're going to start talking about assemblies. So this video is going to be intro to assembly here, a little bit of the basics, but it's actually going to cover a lot of what there is to assemblies. And you'll just have to get creative as the models get more complicated. But I find that doing assemblies is learning how to do assemblies is much easier than learning how to create a fully defined sketch. So we'll dive into this. I've got a couple parts here. So they're individual part files, like everything we've been doing all class. We've been making a single part. It's one file on its own, and that's all we've done so far. So here I've got a little base plate. That's what I called it. It's got a hole in it. Pretty simple. I've got another part file here I'll switch over to. This is just a cube. I colored the sides different colors so you can you'll see when I get here, just kind of help us orient things a little better. But just got a basic cube here. And then I've got a third part that I made, if I can get it to switch over. This third part here is just a pin, real simple, nothing complex about these parts, but I have 3 files open right now. They're all these individual part files. So I want to put them all into one file together where I can actually assemble these things and make something of them. If these were different components for, say, an engine, you could make all of the components separately and then bring them into another file altogether and actually put your engine together. So that's what we're going to do now. I'm going to show you guys how we do that. So what you're going to do is you go to File, New, just like you'd make a new part, but instead of selecting Part, we're going to select the middle button here, Assembly. Click OK. And now we have an assembly file open. So because I already had those 3 files open, that's what it's going to ask me, what do I want to start with? You want to pick you can pick whatever you want really, but try to pick something that's going to be more or less the base of whatever you're building. That'll make more sense as you get into more realistic models, but if you're making a gate that swings open, you'd probably want to start with, let's say, the fence post that the hinges were on, because that's what's anchored to the ground. Kind of pick the thing that you want that's going to be anchored. Again, it'll make more sense as you go. I know it's not a great explanation, but in this case, I'm going to select the base. So I've got the base here. Sorry if my computer's a little slow tonight. It's a little jumpy here. So I got my base. You can see as I move my cursor around, this is moving out here in space. Wow, it is extremely slow. It's just moving around in space as I move my cursor. So I need to place it somewhere. And again, I selected it from the list here on the left of the open files. If you didn't have them open, you can scroll down here and click Browse and find the files in your computer. You don't have to have them open. It just makes it easier. Keep in mind, though, the more things you have open, the slower it's going to make your computer, like mine right now. In fact, probably should close those. We'll see. Anyway, just something to note. This is where you select your parts over here. So I'm going to go ahead and just click anywhere on the screen to place this. And once I do so, you can see it's locked in space. It's not going to move. We can change that, but I'm not going to do that right now. So we've got our base here. Now we need to bring in a second component. So pretty similar to a part file, but you can see the tabs are a little different. So now I have an assembly tab. So up at the top on the assembly tab, I'm going to select Insert Component right here. And that's going to pull up this same toolbox again over here. So I'm going to pick the cube now. Bring the cube in. You can see I can set it wherever I want on the screen. Go ahead and just place it wherever. Just click to place it, and that's where it'll be. Now, as you notice, the base doesn't move when I try to drag it around. The cube will. I can still move the cube after I place it. So the base is anchored in place. And again, you can change that if you want, if you need to move your base somewhere else in space, but it'll initially anchor itself. I'll show you guys down the line how to move the base. But then I've got the cube here and I can put it wherever I want, okay? So I want this cube to be on top of the base up here, sitting right in this corner. That's where I want to put it. I want to make it flush with these two sides and sit right here in the corner. So how do I do that? Well, when we do sketches, we use dimensions and relations to fully define a sketch, right? Similar concept in an assembly. You need to define that object in space. What is it related to? How far away is it from certain surfaces? Things like that. So just like we want to fully define a sketch, generally you want to fully define an assembly unless you specifically want moving parts. But if you don't want anything to move, it should be fully defined as well. So in order to do that, again, the base is locked in place. We want to define, or we want to fully define this cube where it's supposed to be in space as well. So with this cube, let me see if I can even, yeah. With this cube, we want to control it so it doesn't move in the Y direction, that it doesn't move in the Z or the X direction or the Z direction. I'm just looking at my coordinates here. So I need to stop it from going up and down, left and right, and front and back, okay? That's what's known as degrees of freedom. So in an assembly, there's 6 degrees of freedom. That's, again, the X direction, the Y direction, and the Z direction. But there's 3 other degrees of freedom. And again, you obviously know there's only 3 directions you can move in space. But you also have rotation around. Right now I can't spin this. I'll show you later how to actually rotate things. But you have rotation around each of those 3 axes as well. So it's possible to stop this from moving in one direction, but it doesn't mean it can't spin around that point, okay? So when we fully define a part, we need to make sure that all 6 degrees of freedom have been controlled in some way, meaning that it can't move in any of those ways. So again, it's the X, the Y, the Z, and rotation around all of those. So let's start by defining it in the Y direction. That's up and down. We know we want it to sit on this surface, this top surface of the base. We want that bottom blue surface of the cube to touch this surface. So we need to tell the computer that. So up on the assembly toolbar, we have right next to insert component is the mate button. Looks like a paper clip. So we'll select mate. A mate is going to give a relation, more or less, sometimes a distance, sort of like a dimension, smart dimension. But here I have a blue box highlighted on the left, and that's where I need to tell it what surfaces I want this relation to apply to. So I know I want the top surface here on the base to touch the bottom surface on the cube. So I'm going to select both those surfaces like I just did, and you see the cube move a little bit. And if we look at it from the front, we can see that they're coincident. They're parallel to each other, and they're in the same plane. So that's what it's defaulted to, is coincident here. You can see the surfaces I selected and different options. Coincidence is going to make it parallel and touching. Parallel will keep the surfaces parallel, but it can still move up and down. So you really haven't defined it too much. Well, you've defined the rotation. It can't rotate around that axis because it's parallel to this surface. So it won't be able to rotate this way. More on that later. So we've defined that. We said it's coincident to that surface, so we'll click the check mark here. Okay, so now it has one mate. You can see it'll slide along that surface there, but it won't. I can't lift it off the surface. I'll go to a front view here. You can see I can't move it up and down. It'll still slide around on that surface though. So now we need to control it. You can see, again, we stopped it from going up and down, but it still can go left and right and forward and back. So we need to stop that. So I said I wanted it to be touching these 2 surfaces here on the side. So what we'll do here, we'll go ahead and select 2 more. You can see my mate window is still open here. So I'll select the yellow side, and I'll select this side of the base because those are the ones I want to be in line, and it defaults to the coincident mate again. That's what we want, so I'll click the check mark. So now it can't move off that surface, and it can't move up and down. All it can do is move forward and back, so we've got 1 more mate to go. So here I'll select the red surface and the front of the base, And now you can see this doesn't move at all when I try to drag it around. It's been fully defined, and you can see that down here right now my assembly is fully defined. Okay. So there's other types of mates too. What we'll do here is we'll bring in my pin that I made. If I can get it, there we go. There's my pin. Okay, I'll click and place that. I want to put the pin in the hole here, and I want it to be flush with the base, okay? So you can see it's not oriented the right way. There is a way to orient things when you bring them in. Here, I'll go ahead and delete this and show you. So I'll go to Insert again, select the pin, and before I place it, you'll notice I can rotate things down here. So if I want to stand it straight up, I need to rotate around the Z-axis, as we can see there on the coordinate system. So I'll click the Z one time, and that rotates it 90 degrees, and now I'm facing the right direction. I actually don't need it to be facing the right direction, though. That's more for a visual appeal of things. So I'm going to rotate it back, and we'll set it down right there. So the reason I say I don't need to worry about it is because if I select the appropriate surfaces, it'll automatically rotate to meet that condition that I've tried to give it. So I'm going to click Mate on the assembly toolbar again, and we'll select the cylindrical surface of the pin this time. And I want that cylindrical surface to touch this cylindrical surface inside here, right? Those are the two that line up. They'll be touching when I put these together. So we'll select that, and you'll see the pin rotates automatically. Now if you look on the toolbar over here, we've got a concentric mate this time, meaning that these two cylinder shapes fit they share the same center point. Okay, so they share the same center point, and the surfaces obviously are parallel to each other. The pin and the hole in this case happen to be the same size. That doesn't necessarily have to be like that, though. If the pin was a 1/2 inch diameter and the hole was a 1 inch diameter, I could still use the same mate. It's just going to be centered in the hole with a gap around it, okay? So the surfaces will still be parallel, and the center point of that circular shape will still be the same. So that's what the concentric mate does. Really similar to the tangent relation, too. I'm just going to touch on this. That we've used in sketches is the tangent mate. It does the same thing. Take a circular surface and make it tangent to a flat surface, okay? So anyway, I'm still on this concentric mate for the pin. Go ahead and click the check mark. So by doing that, we've controlled, let's see, 4 degrees of freedom. It can't rotate around the X or Z axis, and it can't move side to side along the X or Z axis either, but it can still move up and down. It hasn't been defined where this should be vertically in space. It's hard to see here, but let me see if I can turn my, got my my part origin on there. So, and it can still rotate around the Y-axis. See if I can get it to do it. It's going to be tough. You can kind of see the origin moving there. I'll show you guys in a second. So still got my mate window open here. I'm going to slide the pin up. If I rotate it to the bottom side here, I can select the bottom side of the pin, the flat part of it, and I can select the base, and it's going to make those coincident automatically. It's generally what it defaults to. So I'll click the check mark there. Okay, so now we've controlled 5 of the 6 degrees of freedom. It can't rotate around the X or Z, it can't move along the X or Z, and it can't move along the Y. You can see it doesn't move up and down now, but see how my origin's moving now? I can still rotate it. So in this case, there's ways to define that to stop it from rotating. I'm not going to worry about it right now, so that's going to leave us underdefined. But this isn't going to hurt anything for now. So again, that's just an example of one of the degrees of freedom, and that's rotation around the Y-axis. Okay, so I'm done with mates for now. I'll go ahead and close that. Something else we can do here, I want to bring another cube in. I don't need to go open it and insert it and do all that again. What I can do is hold down the control key, and I'm going to drag my cube. It makes another copy automatically. So now what I can do is a similar thing. I can select the bottom, click mate, or you can click mate and then select the surface. But anyway, I selected, click mate, select this bottom surface here. Go ahead and select the top of the base plate. That's going to make those coincident, just like we did before. I'm going to make it even with the front, so I'll select the front of the cube and the front of the base plate, so they're coincident there now. So you can see this cube will slide along here. And then I don't want this one to be flush in the corner. I want this one to be a certain distance away from the first one I put in. So I'm going to select both those surfaces, and you'll see it defaults to the coincident mate there, so they're touching. But I don't want them touching. I want to have, say, 1.5 inch space between those. So down here I changed it to the distance mate, and I changed it to 1.5. And we'll go ahead and click the check mark there. So you can see those two surfaces, the two I selected, the two yellow surfaces, they are 1.5 inches apart. Oops, didn't mean to add another mate. I meant to be done with that. Okay, so this one, the second one I put can't move, and it's a certain distance away. It doesn't have to be flush with the edge here. You can do whatever you want with that, distance-wise. Okay, so let's go ahead and just show you a couple more things here. I'm going to bring in another cube. Just held control and drag the second one I put in. You could do either one. Okay, let's do this. I'm going to select this edge here on the cube, just the edge. Okay, see the one highlighted in blue? All I did was select an edge. Click on mate. And I'm going to select the edge of the base as well. See that highlighted in red there? So we'll select that. And you can see it defaults to coincident. It doesn't mean my surfaces are coincident. So it can still, it has more degrees of freedom than it would have otherwise. Only the edges are coincident. So I could select this red side and this flat side here, and let's say make a, we'll go with coincident too. Meaning those will stay in the same plane and they'll stay parallel, obviously. But again, I'm only coincident along the edge here. So that means that this can rotate still, see? So if you wanted to make a door hinge or something that moved in this way, you'd use an edge like that to do it, okay? We'll go ahead and delete that. I'm just going to show you one more thing here. Cancel the mate. We'll delete the cube. Just select the cube and hit delete. Get rid of it. Let's make another copy of the pin. I'm going to select the cylindrical surface of the pin and click mate. And then I'm going to click the top surface of the base here. Okay. That automatically makes this tangent to that surface. And actually, let me pull that back up. Your mates, as you make them, will pop up down here, so you can go back and edit them if you want. But that just made these two surfaces tangent. Now, I didn't want it inside the base like that, right? So if you scroll down, you can do this with any of the mates. You can flip the mate alignment down here. So if I click the toggle button, it'll flip it to the other side of that surface. It was touching the underside of that surface. Now it's just flipped to the top. Okay. And so that'll make this tangent with the top surface of the base. I'm going to put in one more mate here just so we can see this better. I made the top of the pin and the side of the base coincident. So let's just switch to a view of the side. You can see that this is tangent. See how just one point of that circle touches that surface? You can almost make a wheel roll on a surface this way. So anyway, just some different mates that you can do. But that's really all there is to it. It's just deciding what surfaces you want touching or how far apart they should be. And then make sure you control them in the 6 degrees of freedom that you want. Usually it's going to be all 6, but if you want some moving parts, you're going to want to carefully choose what surfaces and how they interact so that things can still move. So again, make sure you control everything in the X direction so they can't move that way, or the Y direction, or the Z direction. and then also make sure it can't rotate about that point. So generally you want to select full surfaces. If you're selecting edges or points, then things are going to tend to move a little bit more unless you use a lot more relations. So anyway, this is the kind of the basics of assemblies. I hope that helped, and hopefully you guys can take it from there, reading the book. But if not, I'll do a little bit more of the problem-specific things in the next couple videos, just to kind of help guide you guys a little bit. I'm not going to show you how to do it like I did last week, but I'll show you some of the more complicated mates that they might use in those chapters. All right, hope that helped.